Okay, the next example under surface and line models is we will consider a cycle frame which is made up of hollow aluminum tubing. The tubing has an outer diameter of 25 mm and a wall thickness of 2 mm. The cycle frame is subjected to a loading of 600 Newton at point 2, which is over here, and at the seat, and to a loading of 2000 Newton at the pedal crank, that is point location 1. We have to determine the maximum deflection and the maximum stresses induced. The material that we are going to use for this analysis is aluminum alloy. Now here we can very clearly see that it is a simple problem where we are going to have a uniform hollow pipe structure. So rather than considering this to be a 3D model, we will solve this as a line model problem. So let us understand how to perform this in Ansys Workbench. So again, let me add one static structural analysis system. I'm going to use aluminum alloy for this analysis. So we will enter into the engineering data. Into data sources, we will take the general materials and we will add aluminum alloy. Once that is done, we will return to the project, and here into geometry, we will now create the geometry. So let us have a look at the dimensions first. The dimensions are set into meters. You can see very clearly over here. Now we have this dimension as 0.5 meters. The length is 0.5, the width is 0.4. Okay. So into design modeler, I will go into the sketching tab, and now I'm going to take a rectangle. Okay. Give the dimensions. Now here this dimension is 0.5 meters and this is 0.4 meters. Okay, so this is the small rectangle that we've got. We will add the symmetry constraint. Okay, so this is my design. After this, we will enter into the modeling tab again. Now if you see, we have two more flanks over here, but they are at some angular distance. Okay, if you see, this distance is 0.05 meters and this distance is 0.05 and 0.325. For this, we need to first create a datum plane like this. Okay, so what we are going to do for this is, we will have to create a new datum plane. Okay. Or else what we can do is, we can plot the points over here, and using those points we can also create the line bodies. So I can go into create point option, and here I will say I want to create it according to inputs, manual inputs, right? So you can understand what will be the coordinate. Now see, this is the 0, 0 point. Now this distance is 0.5, so half of 0.5 is going to be 0.25 meters. 0.25 meters plus 0.325. So the coordinates, you can first calculate the coordinates. So I can use my calculator. 0.25 plus 0.325. So this, the value of this point is going to be 0.575, and in this direction it is going to be 0.05. So let us enter these coordinates. So in the x direction it is going to be 0.575, and in the z direction it is going to be 0.005, and we will generate that point. So you can see your model. 0.05. 0.05. Okay. Okay, so this is the point that we have. Similarly, I need the same point on the opposite side. So I will create one more point, and here the coordinates will be x is same 0.575, only z will be negative 0.05, and we will say generate. So this is the point that we get. Okay, now we are going to create a line body, line from sketches. This is the body, and generate. Similarly, I'm going to create line from points, and I'm also going to select this point and this point. Okay, apply, again generate, line from points from here to here, and we will say generate. Similarly, line from points from here to here, generate, and from points from this point to this point, apply and generate. So these are the line bodies. Now we can straight away create a mirror replica of these line bodies on the opposite side. So I can go for create body operations. I need to create a mirror, and I'm going to select the bodies. Okay, now the problem here is the entire body is getting selected as one. So for which now I cannot select this, so I'll cancel this body operation. Okay, and now we will create the points again like we created previously. So I'll go for manual input. Now this is negative 0.575, negative 0.05. This is the point, and then minus 0.575 and 0.05. Now create lines again, line from points, send this, generate, send this, generate, this and this, generate, and finally this. So from this now you can see that the line bodies have been generated. Now the next part is we are going to create our cross section. So for creating the cross section, you have to again go to concepts, cross section, and now according to the problem it is a tubing, circular tubing. So we'll take the cross section, and now we have to give the inner radius and the outer radius. So according to the problem description, the OD is 25 mm. That means the dia will be 0.025 meters. So according to that, the radius is going to be 0.0125, and the thickness is going to be, and the inner radius is 0.0105. Okay, so this is going to be our cross section. Once the cross section is created, we need to apply this cross section to our line body. So select the line body and then apply this cross section. So now the body has been created. If you want to view the body, switch on the cross sections and we can view it. Okay, so this is how we'll create the body, line body. Okay, now once our body is generated, we can then come to the mechanical model. Now once you come to the mechanical model, the first thing that we need to do is we need to set the material information for the line body. So I will come to the geometry tab, select the line body and change the material to aluminum alloy, after which we will generate the meshing. So we have used the default meshing. Okay. Once the meshing is done, we will click on the static structural node and we will apply the supports. So as per the diagram, okay, we have to apply load on point number 1 and point number 2. Okay, So we will add the loads and select the force, and in this case I need to make sure that I'm selecting the point, okay, and see the value on point number 2. It is 600 Newton. And the direction should be the downward direction. And on point number 1, it is 2000 newtons. So I will again go to force, select this point over here, 2000 newtons, define the direction, okay, and we are going to fix these 4 corners, okay, and now we will solve. So we will take the deformation. Now if you see, the stress tools are not available, stress and strain tools, because it is a 1D problem. We need to use the beam tool, and inside the beam tool you will get the stress values, okay. So now we are going to solve the model. So the total deformation you can see is 2.19 millimeters. You can see the animations, and the stress value is 9.0689 megapascal. You can also see the area of maximum and minimum stresses. So please remember, whenever you are solving a line body, we do not have the stresses like the equivalent stress. So you need to come into the tools option and add the beam tool, or you can come into the beam results and you can check the pending moments, okay, and you can also find out the shear forces. Okay. So this is how you will complete the static structural analysis of a line body.